All right, everybody, welcome to Math with Grace. Today we're going to be going through Math 7, Book 710, Lessons 6 through 10. Lesson 6 begins on page 23, and it's titled Diagonals of Polygons. It says here a line segment that joins any two vertices of a polygon, but is not a side of the polygon, is called a diagonal. So normally we would say any two non-adjacent vertices, like these two vertices are adjacent. The only line that can connect them is the side of the polygon. But these two vertices are not adjacent. They are not right next to each other. They are diagonal from each other, okay? And so it says here that a diagonal may or may not be a line of symmetry. In this case, it is not a line of symmetry. If I fold this shape in half along this line, these two sides would not match up. But here in this square, it would match, right? They would match up perfectly if I folded it in half. It says here a triangle has no diagonal. I tried to combine those two words, right? Because none of its sides are non-adjacent. They're all adjacent to each other. This side is right next to this side, which is right next to this side, which is right next to this. There is no non-adjacent sides, okay? So it doesn't have a diagonal. But squares do. Pentagon has 5, right? Quadrilateral always has 2. A pentagon always has 5. The more sides your polygon has, the more diagonals it has. So for this next part here, they want us to take a ruler and draw some diagonals, okay? Now remember, we are connecting non-adjacent sides. So sides that are not right next to each other. We just read that a quadrilateral has 2 diagonals and a pentagon has 5. So let's go ahead and draw those in. 1, 2, 3, 4, and 5. Makes a nice little star. Okay. What about this? This is a quadrilateral, so even though it is not a square or even a rectangle, it still has 2 diagonals. Okay. And then it asks here, is the line drawn through the polygon a diagonal? Right, yes or no? So, do I have a line drawn through 2 non-consecutive or non-adjacent vertices? Yes, I do. What about here? No, it's not even drawn through any vertices. So, nerp. This one? Yerp. Yes, it is. Okay? Diagonals, pretty basic stuff. Go ahead and finish the weave. Remember, meet me back here when you're ready for lesson 7. Lesson 7 begins on page 27, and it's titled 24-Hour Digital Time. It says some digital clocks divide the day into one 24-hour period instead of 2 12-hour periods. When I think of the 24-hour clock, I think of military. The military uses a 24-hour clock. For most people, it's kind of confusing, but we're going to take a look at it, right? So 24-hour digital time helps avoid the confusion in knowing whether a time is in the morning or at night, AM or PM, right? Afternoon and evening times, 1 p.m. and later, can be changed to a 24-hour time by adding 12 to the hours. If you think about it, if you're in the afternoon, 12 hours have already gone by in the day, right? So to get a 24-hour time clock, we just add that 12 hours. So it says 5 p.m. is 1700 hours in the 24-hour time clock. Noon is still 1200, right? I'm not in the military, so maybe they say it a little bit different, but 1200 hours, I think, is what they say. But midnight is 2400 hours, or if you consider it to be the end of the day, if you consider it to be the beginning of the day, then it's I don't know, what is it, 0 o'clock? For the start of the next day. So 10 minutes past midnight is 0:10, or 0:10 hours, okay? 10 minutes past noon is 12:10, okay? Again, I'm not part of the military, but I know the military uses this type of clock for their uses, okay? Let's turn the page. So at the top of page 28 it says, this airport timetable displays 24-hour digital time to show departure times of flights throughout the day and night. If your plane is leaving at 20:55, you will want to be there well before 8:55 p.m. to catch your flight. How do you get from 20:55 to 8:55 p.m.? Well, we subtract 12, okay? Any number here that is larger than 12, we subtract 12 from to figure out what time in the afternoon it is, okay? So here is the departure list, right? So 14:50 is what time the flight leaves for London, 14:50. If you take 14:50 and you take away 12, okay, you're left with 2:50. The flight is at 2:50 p.m. Okay, so you better be there by probably 1 at the latest. Okay, give yourself a little bit of time to get through TSA. All right, write each of these in 12-hour time and follow the first two examples. They're done for you. 11:10, okay, 11:10 in a 12-hour time is just 11:10 a.m. Okay, it's not greater than 12, so we don't need to do anything to it. Okay, that's just what time it is. 16:05 is greater than 12, so if we take 16:05 and we subtract 12, right, what do we get? Well, we get 4:05, right? So this is at 4:05 p.m. 23:50 and subtract 12. Here's our 50, right? 1, so 11:50 p.m. Right? If you have to subtract the 12 or you have to add a 12, then it is the afternoon. It is the p.m. Okay, it's afternoon. 17 minus 12 is 5 p.m. 09:45. So 09:45 tells me that it is 9:45 a.m. Okay, if it is 0 something, then it is a.m. So like this one was 0:35, it is 12:35 a.m. We are just barely in the morning, just barely past midnight. Okay. 21:45 minus 12, okay, is 45. What's 21 minus 12, right? 9, okay? So 9:45 p.m. and 00, like, I don't know how they say it, like how you would actually read that, but it tells me it's midnight or 12 o'clock a.m. Right? I think that the 12 o'clock a.m. hour, like the 0:35, is probably one that confuses people the most, because technically, right, we added 12 to this, so it should be a p.m., but we didn't. The 00 kind of stands for 12. That one's probably the trickiest one. All right, let's look at these other ones where we're switching over from the 12 to a 24-hour clock. So 1:06 a.m., right? Remember the AMs we don't change, so this is just going to be 01:06. That's the time. We leave off the AM. 9:40 p.m., though, we do have to add 12. So we have to add 9 plus 12. Okay? And so what is 9 plus 12? Well, it's 21:40. Okay? 3:35 p.m. We're going to take 12 plus 3. or 1535. We don't have to write AM or PM. This is how they get away with not having to worry about that part, okay? 11:55 p.m. Okay, this is night. We have to add 12. So 11 plus 12 is how much, right? It's going to be 23:55. We're almost at midnight. 24 hours in a day, okay? What about 12:30 a.m.? So this is the part that gets people tricketied, right? 12:30 a.m. is just going to be 0030. And I don't know how you would say that in like a military or whatever when you would read this. Maybe in other countries, Europe or something, they use the 24-hour clock as well. I'm not really sure. 2:05 p.m. We're going to add 2 plus 12. So 14:05. 2:05 a.m. though is going to be 02:05. Okay, so you see the difference? PM 14:05, AM 2:05. All right. So that's a 24-hour clock. It's a little confusing maybe if you've never really thought about it or worked with it before. We use 2 12-hour days, right? We have AM, not 12-hour days. We use 2 12-hour time periods for our day. We have the 12 hours of the morning and the 12 hours of the afternoon, PM and AM. But some places, and definitely in the military, they use a 24-hour clock. So there's no confusion. If you said, oh, yeah, I'll meet you at 8. Is that 8? Are you coming at 8 in the morning? Are you coming at 8 at night? You know, you have to clarify. But this way, with this method of using of time, you don't have to clarify. You're either coming at 8 or you're coming at 20, right? So that's how that works. All right, go ahead and finish the We Remember for Lesson 7. You can meet me back here when you're ready for Lesson 8. Lesson 8 begins on page 32, and it's titled Graphing Linear Equations. So remember, a linear equation looks like this. Y equals x plus 2, and it can be graphed. And one way for us to graph this is to make a table of values. And so we're going to slide over here to page 33. And we're going to see what that means. Here is our table of values. What it would look like before you begin is probably, this would be blank. Not probably, it would be. You would have your x values, and then you'd have your y, but they would be blank, okay? You would choose some values for x, so they chose 0, 1, 2, and 3, and then you would substitute those in to your equation to solve for your y. So, if x equals 0, then 0 plus 2 is 2. So when x is 0, you always start with x. You always assign a value to x, okay? X is the independent variable. You always assign the value to it. And then you determine the y. So when x is 0, y is 2. When x is 1, 1 plus 2 is 3. So when x is 1, y is 3. Okay? When x is 2, 2 plus 2 is 4. So y is equal to 4. When x is 3, 3 plus 2 is 5. So y is equal to 5. Now you have your set of ordered pairs. This example is very spread out. Now you have your set of ordered pairs that you can graph, and then connecting those dots to make your line. Okay? All right, now they only have quadrant 1 of our coordinate plane here, but remember our coordinate plane goes in all directions. Okay, let's turn the page and take a look at some of these problems together. So here we are at the top of page 34. It says solve the equation for each value on the table and list the ordered pairs. Then graph the equation. They started the table for you. Okay, we have x plus y equals 6. First thing that we want to do to solve this, and they don't necessarily do that in their example, but I want you to start doing it because it will help you in the long run, is we want to solve for y. We want the y to be by itself, okay? Right now, the x and the y are on the same side. The x is positive. We're going to solve for y just like we would in any equation, right? X is being added to y, so we are going to do the opposite and subtract the x from both sides, okay? And I know that this is kind of 2 lessons in one, because it's not really what this lesson is about, but trust me when I say you will be doing this for the rest of your mathematical career here, and therefore this is a great place to start. Okay, so when I subtract x minus x, just like any other equation that we've done, right, is 0. So I'm left with y equals, now the 6 and the x I can't combine, right? They're not like terms, so it's just going to be 6 minus x. Okay? Now, when I go to solve, when I substitute and solve, this is going to be so much easier. It's already set up. I don't have to, they're doing it here. They're just doing it in a different order. This way, it's already set up and ready to go. So, we have 2 done for us. We're going to do the third. What about when x is 3? So, y equals 6 minus this negative is part of the equation, and x is a 3. So 6 minus 3 is what? Well, 6 minus 3 is 3. So my ordered pair is 3 comma 3. What about the next one when x is 4? Y is going to equal 6 minus 4, right? When x is 4, I'm substituting that 4 in. 6 minus 4 is 2. So my ordered pair is 4 comma 2. And what about when x is 5? Well, y is going to equal 6 minus 5. 6 minus 5 is 1. So my ordered pair is 5 comma 1. Okay, plotting our points. Our first point is at 1 comma 5. So remember, our points are always plotted x comma y. So for me to get to a 1, I'm at 1 on the x, and then I go up to the 5 on the y. Okay, 2 comma 4 is here. 3 comma 3 is here. 4 comma 2 is here. 5 comma 1 is there. Taking out your ruler. Remember, this is a linear equation, so technically it goes on and on forever, amen. So we want to draw arrows at the end of our line. Okay? All right, take a look at the next one. This one is already set up in the way that we need it. I usually like to write it the opposite way. So 2x minus 1 equals y, then y equals 2x minus 1, right? We just switched it around. So now we can substitute our values for x. So what about here when x is equal to 2? Then y is going to equal 2 times 2 minus 1. Or 2 times 2 is 4. 4 minus 1 is 3. So our coordinate, well, let's write the first one in, was 1, 1. The second one is 2 comma 3. The next one, x equals 3. So y is equal to 2 times x, or 2 times 3 minus 1. 2 times 3 is 6. 6 minus 1 is 5. So our next coordinate is 3 comma 5. And finally, we have x equals 4. So y is equal to 2 times x, or 4 minus 1. 2 times 4 is 8, minus 1 is 7. So I'm at 4 comma 7. Now, when you plot these and you go to draw your line, if you cannot make a straight line with your points that you've plotted, then you've done something wrong, okay? Check your points, your actual plotted points, and if you plotted them exactly where it says, then go back and check your math, okay? If they don't line up, then it's not a linear equation, right? But these are, so you've made an error. Let's do our first point, 1 comma 1. So remember, x comma y. 2 comma 3 tells me x comma y goes there. 3 comma 5, so over 3, up 5. 4 comma 7 goes over 4, up 7. All right, take out your straight edge. Please get comfortable drawing your arrow all the way outside of your grid. Okay, if you were in my physical class, I would say I want your arrows to go all the way outside of the grid with your little arrows on the edges. Show me your line. Okay, it goes on and on. Don't just like, some people like to go like, oh, here's my line. No, no, no. It should extend all the way out so we can see all the bits. Okay, arrows on both ends because lines go on and on forever. Amen. All right, so my suggestion is to set it up in a y=, form. We did that on this one here, right? We had to do one extra step, but that helped us when we were substituting. We're going to solve for our coordinate pair. We're going to plot our coordinate pairs and make our line. Great job. Go ahead and finish the We Remember. Meet me back here when you're ready for Lesson 9. Lesson 9 begins on page 38, and it's titled Double Line Graphs. So it says here a line graph is used to track the change in a particular value over time. When two values are tracked on the same graph, we can see how the changes in the two values compare with each other. Okay, here's our example. Somebody who was at Raymond enjoys tracking the weather on a farm, and he used the line graph to show the daily highs and lows for the first week of May. So here were the high temperatures, okay, and here were our low temperatures, and so he was able to track them, and by putting them both on the same line graph, we can see how the day went from sometimes pretty low to pretty high, and another couple of times the temperature change wasn't that drastic. All right, so some questions here. Answer the questions about the above graph. What was the range of high temperatures? Okay, remember the range is the highest minus the smallest of the high. So the highest high temperatures, right, are here, 85. And if we subtract the lowest high temperature was 65. So that would give us the range. The range is 20 degrees. Okay. What about the range of the low temperatures? So again, to find the range, we take the largest low temperature and subtract the smallest. The largest low temperature was 60 degrees. The smallest low temperature was 45. So it had a range of 15 degrees. Which day had the greatest difference between the high and the low temperatures? So which day had the highest difference? Well, if we look here, we went from 45 to 70, which is a 25-degree change, okay, because these are all fives, right? So 5, 10, 15, 20, 25-degree change. Then we had this that went up 5 degrees, but this didn't. So we have 5, 10, 15, 20, 25 plus, we're making an estimate here, maybe 28 degrees, let's just say. And then I think the other one that's close is this one here. So 5, 10, 15, 20, 25, 30, right? Let me just check. 1, 5, 10, 15, 20, 25, 30. Yeah. So 32-ish degrees, maybe 31 degrees was this change. So because we have to estimate, I would say which day it was. I guess that's all they're asking. And that's a Friday. Friday, I feel like, was the biggest difference. Okay, because we had to estimate. So which day had the least difference between the two temperatures? It's definitely going to be this 10-degree change day that's here, and that was Thursday. Funny that, the greatest difference is Friday, but the least difference was Thursday. Interesting, right? All right, top of page 39. Draw a double line graph of the information given in the table. Label each line to show whether it represents gasoline or diesel fuel. And it says the price per gallon of gasoline and diesel fuel for the month of May is shown on the table. We need to figure out or finish labeling this. So it looks like they're going every other line by 10 cents. So this is going to be $2.70, $2.80, $2.90, and finishing off at $3. Man, let's go buy fuel here. And then we have the weeks. Week 1, 2, 3, 4, 5. So here is the weeks, and this is the cost. Okay. So let's start with our gasoline, and then we will do our diesel fuel. We'll do one line at a time so that our points don't get mixed up. So week 1, our gasoline was $2.85. So that's going to go here. Week 2, it is $2.90. Week 3, it is $2.95. Week 4, it is $2.90. And week 5, it is $2.85. Now, you could use a different color if you want to do your diesel in a different color. That is totally acceptable, but it's unnecessary if you don't want to. What we're going to do to differentiate between our two fuels, right, just like they did over here, we're going to label this. And so we're going to call this one gas. Just like that, okay? Now, our diesel fuel is $2.65 on week 1, which is this spot right there. $2.60 on week 2. $2.70 on week 3. $2.60 on week 4. And $2.60 on week 5. Okay? I remember a time not that long ago when diesel was cheaper than regular fuel. I don't know if that time will ever return, but we shall see. All right. So it looks like that, and this is our diesel. Diesel. All right. And there we go. That's our double line graph, right? Like I said, you want to plot all of one thing first, so you're not getting your line, because sometimes they do cross each other depending on what you're labeling here, what you're trying to see. So sometimes they do cross over each other, which is fine. So we just want to plot all of one and connect them first and then do the other one. Make sure you label your lines. Make sure you label your graph. Okay? And that's it, right? It's a line graph times 2. Sometimes we can do times 3, maybe even. All right? Line graphs can be used to show comparisons as well as the information that they're listed. All right. Go ahead and finish the wheel. Remember, you'll be ready for your quiz 2, which is in the back of your book. As always, if you have any questions, do not hesitate to contact me. Otherwise, until next time.